Hi everybody. Let's kind of get started here, right? I think it's past time. Yeah. Let's get the show on the road, right? Taking the test, scores are in and entered on minority. I still think I have one or two still waiting to take, so I'm gonna hold off on passing those back until next week. Today though, starting chapter 7, and this is going to be the run of several chapters all centered on statistics. Really from now till the end of the semester is going to be all statistics all the time for us. Yay! So hold on to that. If you're coming from an AP Stats class, I think I had a couple of people in the other section that were in AP Stats already. Should be no problemo. Everyone else, though, we're going to treat this as it's the first time you're seeing these things. So if somebody's just like, how the heck do they know all this already? Might be because they already learned it in their AP Stats class. So don't be like freaked out like, I don't know any of these things. Bobby over there seems like he has every answer. Mr. School can't even get it out of his mouth. So we're going to start talking about statistics. We're going to start real slow. There's going to be no computation here in this first section. There's nothing to compute. It's going to be talking about like how to do things, but not like no numbers. That being said, kind of at the back of your minds while we're doing this and talking about these things, you should be thinking about your IA, right? Remember, we have this math paper that you guys are going to write. Bless you. During this first semester, it's going to count as your semester exam. There is no written exam for this class. It'll just be your paper that you're going to write for me. We'll probably be looking at topic selection here sometime during chapter 7. So just kind of be thinking about that. So in this section, we talk a lot about sampling and how we're gathering our data. These are things that would be relevant for your IA to start thinking about, like, what's a topic? Can I actually gather data on that topic? Can I gather data well on that topic? We'll talk about how to gather data during this string of notes. So while we're doing that, I would be thinking about my IA and potential topics or ideas, kind of get that moving in your head. We'll have like a sign up for that later on in this chapter, though. Okey dokes? So again, we're going to have a string of chapters where the overarching theme is statistics. So let's start by defining that word. Science of data. It's very descriptive. It's good. Thank you. More useful to us, though, is what you do with the statistic, which is called data analysis. So that is the process of organizing, displaying, summarizing, and asking questions about the data you've collected. So the displaying and summarizing is probably done via creating a graph or doing some statistic, doing a calculation. So when we talk about, most of what we'll talk about today is going to be the organizing, which means collecting data, deciding what information that you need, or even what question are you interested in asking. So in that organization process, there's really two things that you want to consider. You want to consider the population, that is the objects or individuals that you're interested in studying. So again, if you're interested in like studying something about high school students, their population can be high school students. But it could just as easily be things, right? Like if you are running a manufacturing facility and you want to do a quality control on the product you're producing, the population that you could be studying would be like widgets or whatever your factory is producing. The other component that you want to think about is the variable. That is like the characteristic of that population or individual that you're kind of looking to study. So if you're talking about high school students, maybe you're looking at your variable is like academic performance. Or if you're talking about, like a quality control situation, maybe you're producing like jars of pickles and you want your pickle jars to have between 25 and 30 pickles in them. Your variable would be like number of pickles in a jar or something, right? Everybody okay with the idea? When we talk about population, doesn't necessarily mean human beings or animals or something. It could be things as well. So typically we separate the measurement of a variable into two types. There's qualitative variables, which separates the population into groups or categories. So for example, like if I surveyed this class and asked your favorite color, it's a qualitative variable. Or if I asked, like what kind of TV shows do you like to watch, qualitative variable. You guys get the idea? The other type of variable is quantitative. Quantitative variables take on a numerical response. So if I asked your height, it's a quantitative, or your weight, or your GPA, or your shoe size, all of which are like quantitative variables. Again, you should see the word quantitative and think quantity, that's a number. Qualitative, quality, that's like a description, so it's usually a word. Right? So like political party of presidents is a qualitative variable. Right? It's not a number, it's like a word. Everybody feel good? Okay. So quantitative data can be grouped into two different kinds of categories. You can have discrete data and you can have continuous data. Discrete data are things that can take on only certain values. So for example, shoe size is a discrete variable because you can have like a size 9 or size 9.5 or a 10, but there's no size 9.6, right? It's discrete in that fashion. Can someone think of another example of a discrete data?
Like how many pets someone has or something?
Great, the number of pets somebody has. Perfect. You can't have 0.5 of a pet, right? Or like the number of people in a family. It's discrete. You can't have half a family member, unless you're counting like half siblings or something. But that's not really a half. Like either they live in the house with you or not. Like, everybody kind of get the idea there? So the other type is continuous. So things like height or weight are continuous because someone can weigh 100 pounds, they can weigh 100.1 pounds, or 100.01 pounds, 100.001 pounds. As long as you have an accurate enough scale, you can measure that weight down to any number you want, right? I mean, you need a tool in order to do it, but like, there's no limit on what the possible values of weight would be. Everybody agree with that? Another example of a continuous data. These are usually easy. What's another continuous variable? Give me an example.
Something money-wise.
Money, right? Sure. To some extent, anyways. Depending on how you're defining money, because is there anything between 1 cent and 2 cents?
Oh, well, no.
It depends, right? Like if it's you as a person, no. If you're a financial institution like a bank, heck yeah, they're tracking fractions of cents. Because when they calculate interest, there's fractions of cents calculated. Have you ever seen the movie Superman 3? Now this was back in the 80s or whatever, so it's like a long time ago. One of the plot points is, Richard Pryor, who's a comedian from the 70s, was like apparently some kind of computer genius and didn't know it. And one of the plots in the movie is he writes some program and puts it into the banking software that just steals all the fractions of cents that are created and like becomes the richest man in the world by doing so. It's like a plot point in the movie from the 80s. Office Space, I think it's also a plot in that movie. I think that's the program in the end where they think they're going to get caught stealing the company's money because they steal more than a fraction of a cent because the guy puts the decimal in the wrong place. You have Mr. Davis for one of his lit classes. You definitely the salesman. I think you watch Office Space, so watch out for that plot point. So to my point though is that Brody's answer of money it like depends on the context, right? So like talking about your own personal finances, there's no fractions of cents; it's discrete. Talking about a banking institution though, they do track. They can track monies down to fractions of cents like that. I would consider that continuous there. How about another one, continuous?
Like your GPA, because it can go to...
Great, GPA for sure. Again, you can take really any value from 0 up to whatever, depending on your courses that you're taking. Those can be lots of possibilities. Like height. Distance between 2 points, like how far something is away. Lots of things can be continuous like that, right? Worth noting that qualitative data is always discrete data. Right? If I ask you your favorite color, there's not like, I have 0.75 orange. Like that doesn't really like that doesn't compute, right? Like you can't have a fraction of orange. It's either orange or it's some new color. Right? There's not like so again, when we're doing this kind of data analysis, our variable can take on lots of different values. One of the first most basic analyses we're going to do is you're going to just see how many times a variable takes on a given value. That's called the distribution. So if you look at the example here, we've listed like a bunch of different models of cars and the fuel efficiency, the miles per gallon each of these different models of cars gets. If I collect all of these together, I can make like a display. So I take all those miles per gallon, I like plot them on an x-axis and like put a dot above that specific mile per gallon each time I see a car that has that miles per gallon. That graph is an example of something called a dot plot. We'll talk more about graphing data later. But that picture represents the distribution of miles per gallon. And at some level, our very first kind of analysis we're going to do is just going to be looking at the distribution and talking about what we can see from that. No calculation, just looking at a picture of how the data is arrayed. Everybody's doing okay? So, we've collected some data. Typically, the first step is then to graph your data. After that, you might add some kind of numerical summary. We're not talking about how to do any of that stuff yet. So that's the typical process in the slide there. I thought there was one more thing on that. Kind of the typical workflow in statistics. You know, like you take a variable and a population, you gather some data, start with a graph, do some numerical analysis. That's kind of the typical workflow. I am a little bit. Where's my noise? So, when we talk about like the process in general, not just the data analysis piece, but like the whole process, the whole goal of this, is you're going to start with a population, large group of individuals that you're interested in. You take a sample of those individuals somehow. We'll talk about how to do that sampling in a minute. You'll collect data from that sample. Ideally, it's a representative sample. We'll talk about what we mean by representative. If you're doing your job well, you're going to take that data that you've collected and analyze it. So you'll look at the graph, you'll do some calculation, you'll make an inference. So like, what does this data tell me about the population as a whole? So that you can say something about the group from just looking at a set of individuals. What time do we get ourselves together here, ladies? Yes. Sure. So let's just kind of talk through like a hypothetical here. So suppose my population is high school athletes. Okay? I take a sample. So let's say I took the Notre Dame Prep football team as my sample. I decide the variable in interest is like academic performance. So I collect some GPAs from our football team. I do some data analysis. I find that like the average GPA on the football team is above the average GPA in the school. So I make an inference that says that participating in athletics improves your academic performance. That would be the inference. Right? That's kind of, in terms of like the workflow, that's what we're going to be doing. That's essentially going to be your IA. Now, what's the hardest part on, or the hardest step here? What do you think, which one of these steps is the hardest step? Yeah, it's choosing a representative sample and collecting the data. That is the part that if you screw that up, everything downstream is going to be like invalidated, right? So the biggest, the most important piece is making sure that like you're targeting the variable in question from the population. You're doing so in a way that's like representative, it's meaningful, it still matches the population you want to study. Now, in my example, did I do a good job of creating a representative sample? If I wanted to talk about all high school athletes, and I sampled just the football players from this school? No, right? For a variety of reasons. There could be many reasons why this is no longer representative. You know, this school is a private school, you have to apply to get in, not everybody that would want to go here can even go here, even if they can afford to pay to go here. Not everyone is admitted. The demands of the football season from a practice standpoint and a outside of school standpoint, time commitment differs between other sports. Some sports seasons are longer than others. Like I think the hardest one is the ones that run winter from like one semester into the other. Academically, I think those are the hardest ones. Like the swims and basketballs and wrestlings and where you're chewing up 2 different semesters, I think is really difficult academically. Or skis. I don't know if ski really starts before Christmas break, but I feel like it does. But that's so there's a variety of things going on there, not to mention that football teams typically one gendered, just looking at boys rather than boys and girls. Again, not very representative of all high school athletes if you're only looking at one gender. Lots of reasons why that would have been a bad sampling. Alright, so let's talk a little vocab here. So I want to talk about the difference between a population, a census, and a sample. So the population is the entire group of individuals that we want to get information about. So it could be all American high school students, or all high school students worldwide, or all people worldwide, or all traffic accidents, or all traffic accidents in Michigan that involve a cell phone. Or it could be, like the population just can be whatever you want it to be, but it's all individuals that meet some criteria, right? Or it could be things like all iPhone 17s or whatever. I don't even know what number they're on. Mine is. A census is when you go and collect data from every single individual in the population. So the federal government, every 10 years, conducts a census of U.S. residents, not citizens, residents, where every single person that lives in America is they want them to fill out some demographic information. They use that information to decide, is this area, city, or whatever, is their population growing or shrinking? Do we need to add more services? Is the demographics of this population changing? Are there more children now? We need to add some more school services. Build another elementary school. Add some more pre-K services. Do we need to, improve the public transportation because we have more people living and working in one area? So there's all sorts of reasons the federal government is going to want to collect this data because they use it to justify spending on programs or initiating programs to the American population. What's the problem with a census? You're trying to collect data from every single member of a population. It's really hard, right? It's hard in that it's time consuming, it's expensive. You're talking about finding every single resident. You're talking about people that don't have a fixed address, don't have a phone, might be here illegally. You're trying to find and locate all of these people. To do that, federal government hires caseworkers at the city level. They go around and try to find these people that either haven't completed their census materials and submitted it, or the people that don't even have, a place where we know that you were there anyway. They go out looking for people that aren't normally easy to find. Everybody okay with that? So again, census, difficult because it's time consuming, expensive, really expensive. Sure. Imagine just if you are running a manufacturing business, like you're making something. If you're doing quality control, are you inspecting every single item that comes off your production line? Probably not. If you're producing millions of items a day, boy, that's insane, right? Like that is so expensive and time consuming. Now, if you're building if you're Henry Ford and we're knocking out 25 cars a day, maybe we can inspect all of them. If you're on a modern assembly line where you're cranking out hundreds or thousands of cars a day, much more difficult to inspect every single item at every single step on a production line. What you'll typically do is you'll do some kind of sampling of that. We'll check every 10th item that comes off, or every 100th item, or every 1,000th item, and make sure that as we're running this production, that it's meeting certain specifications in our sample, right? So a sample is just some subset of individuals in a population that we actually collect the data from. And we hope that that sample can represent the population as a whole, right? And really where the rubber meets the road, what makes separates a good researcher from a mediocre one is how good they are at selecting their sample. That becomes one of those skills that's really underrated. Can we design an experiment that isolates the variable that we really want and can give us a sample that can really stand in for the population as a whole? And can I do that cheaply and quickly? Right? Because you could always just do a census, but nobody is paying you the money it would take to do a real census of anything. So we say a parameter is a numerical characteristic of the population. So, you could talk about adults over 55. The parameter is your age, right? You could talk about, professional football players over 300 pounds. The parameter is their weight, the 300 pounds. A statistic is a numerical characteristic of a sample. So maybe it might be the average weight of NFL players over 300 pounds. That's a statistic that you've gotten from the entire population. It's not the data of one individual. It's something meaningful to the entire group. So the entire point of doing this, of collecting a sample and doing some statistic on it and analyzing that statistic, what you want to be able to do is you want to be able to come to the end and be able to say something about that variable's effect on a population. So again, you have your population, take a sample, collect some data, do some analysis, and then you want to make an inference that's true for that sample, and you hope then is true for the population. Right? So if you work as a political consultant, you might try to create a sample where you can ask the people about their opinion on some issue. If you did a good job creating your sample, that should stand in for the population of the whole, so your political candidate could know which way the population, the people he's representing feels about this particular issue. Right? Okay. So again, yes, sure. The idea here is to be able to draw conclusions about the whole population based on just a few people, relative few people, we should say. Oftentimes, your sample might be thousands or tens or thousands or hundreds of thousands of people, but we're talking about a billion. That's relatively few. So let's talk about methods of choosing that sample. This is the part where this will be directly relevant to you when you're ready to start working on your IA and start collecting data. And then when you're writing your IA and talking about how you did what you did, right? Explaining what you did and why you made the choices you made. So if I'm going to start collecting a sample, I want to start by defining the population that I want to study. I want to say then exactly what I want to measure. So if it's academic performance in high school athletes, or the amount of time spent on a device and your relative happiness, or the number of pets in your house and how much poop you have to handle, or whatever the thing might be. It doesn't, you'll then create a sample survey. So if you're giving this to individual people, you're probably going to ask them questions to collect your data. If you have a pre-existing data set, you'll just be like skimming that data set for the relevant information. So for example, you might think, or you might look at, the home run rate of Major League Baseball players in relation to their, yearly salary, right? In that case, you're just going to look at all active MLB players and select your sample from that. Your survey will be you just skimming that data that you want from a publicly available data source, as opposed to asking individuals some questions. And then step 3, once you've decided who you want to study, how you want to measure it, you have to figure out how you're going to pick the people or the individuals you want to make your sample from. And that's what we're going to talk about. The remainder here is that sampling procedures. The gold standard in statistics, statistical sampling, is a random sampling. Now you can do random sampling a bunch of different ways, but if you're doing sampling, boy howdy, the best way to do it is to randomize it. When we talk about random sampling, it means that every individual in the population has the same probability of being selected for the sample. So there's no preferences given. Every individual has the same rate or possibility of being chosen. The most basic type of random sampling is a simple random sample, where essentially you're going to take every individual in the population, you assign them a number, and then you randomly generate however many numbers you want to include in your sample, whether it's 10 or 50 or 100 or 10,000 or whatever. And then those are the individuals you use. So in practice, randomly selecting people. If I want to select random students from this room, I could write down all your names on a slip of paper, put them in a hat, mix them up, draw out names like that. That's a random sampling. If your population is big, that's stupid though. Who has time for that? You don't do it that way. You do it electronically. You let a computer randomly select your people. We'll eventually show you how on a calculator to select randomly numbers between 0 and 100 or whatever. So this is the process I just described there, where you number everybody in the population and then draw however many random digits you want using a computer of some sort, whether it's a calculator or Michigan or whatever. Now, sometimes there's advantages to using a more complex random sampling method. So one of those would be like a stratified random sample. So the idea here is that maybe you're really concerned about, your sample matching some characteristic of the population. So if we talk about measuring high school athletes and academic performance, maybe the stratifying that I want to do is I want to make sure that my sample, the amount of boys and girls, the ratio of the boys and girls in my sample matches the ratio of boys and girls in high school athletes nationwide. So what I could do is I could make one strata of boys and one strata of girls, and make sure that if 60% of my athletes are boys nationwide and 40% are girls, then when I do my simple random sampling for my strata, 60% come from the boys and 40% come from the girls. Is everybody okay with that? So that's a way to make sure that your sample at least meets some representative attribute that you're particularly concerned about. Another type of sampling is systematic sampling. Now, this has some drawbacks, because we're losing the random piece of this. But what we're picking up is convenience, or ease, or cost. This is cheaper, easier, more convenient to do. So in a systematic sample, you start by looking at the size of your population. You decide that okay, I want 100 people in my sample. So I take the size of my population, say it's 1,000 people, divide it by 100. So 1,000 divided by 100 is 10. I want to select every 10th individual. Are you okay with that idea? Whether it's looking at books in a library and just walking along the shelves and looking at every 10th book, looking at names on a roster, taking every 10th name, looking at customers entering a store, stopping every 10th person to ask them. All of those are examples of ways which systematic sampling might make a lot of sense. So think about the difference in convenience, right? If you're talking about randomly choosing people from the school, now you have to track down these specific individuals, or you could stand at the front door and just stop every 10th person who walked in. One of them is way easier for you to do than the other, right? When you talk about time and as a cost, one of them is going to take way less time than the other. That's why you might choose a systematic sampling method over a random sampling method. It just might not be feasible with your constraints, whether time or money or whatever, to do a true random sampling. So another way that you can random sample, so again, even with stratifying, sometimes if your population is very big, if you're talking about all high school athletes, even if I separate them into boys and girls and randomly sample from them, you're talking about finding people in California, and Alaska, and Michigan, and you're all over the place. This is tough to do, right? One way to make this a little easier is you might also cluster or look at taking samples just from certain clusters. So I might go to 3 geographic areas. I might look at California, Michigan, and Florida. And then I can further stratify from there and random sample just in those 3 states. and think, well, that's probably representative. Those are three pretty populous states. Maybe I'll just pull from there. Now, there's obvious downsides of that, but or instead, if you're talking about like politics and you live in Michigan, maybe you're just going to sample people in Michigan and hope that, like, maybe I'd sample some East Coast people, East Coast of Michigan people, and West Coast of Michigan people, and like, go to Grand Rapids, go to Metro Detroit, maybe go to Lansing, somewhere on the east, east, west, middle, sample, 3 clusters. Heck of a lot easier. That's way less travel than if I'm randomly sampling people and I end up with in the Upper Peninsula and down in Southeast Michigan and like up by Traverse City, and I'm driving around all over the place trying to track these people down. Yuckarooskies. Maybe I can just cluster this geographically. So let's talk about how to sample badly. So bad sampling methods. One of the worst ways you can do this is pure convenience. So if I want to study all high school students, and I just say, okay, I'm going to survey the kids in my high school. Not great. I mean, it's something. Why might you settle for a convenience sample even though you know it's not great?
Less work.
Might be the only realistic option you have, right? Now, there's always things you can do to try to clean that convenience sample up a little bit, but at the end of the day, if you're just like, checking the political affiliations of your neighborhood and saying that's representative of the whole country, tough to sell that that's going to be a great method. You may get lucky and it might, your inference might prove out to be correct, but your methodology was suspect. Everybody's okay? So let's think about why convenience samples could produce unrepresentative data. So again, if we're talking about trying to talk, our population is all high school students. We sampled just for Notre Dame Prep. What are some examples of attributes that Notre Dame Prep has lots of, or more of than the population as a whole, or has way less of than the population as a whole? If you're talking about high school students. Come on, guys. It shouldn't be that hard. You all go here and live here.
I remember Catholics in school.
Okay, so religious affiliation for sure. Probably way outweighs the religious denominations in any school in general, if you just randomly choose a school, for sure. Brody?
I think we have a pretty small student-to-teacher ratio.
Okay, student-to-teacher ratio, perfect. Public school, you may end up with 30, 40 kids in a classroom. Doesn't really happen here. What else? Some other examples. Think about the actual people that are attending here.
People that work hard in class and don't just
Okay, you have a very motivated student population in general. There's probably less, missing work and problems of that sort because of the population you're dealing with. How about, racial demographic? School is not terribly diverse compared to the country in general. How about socioeconomic? Your student population is pretty wealthy compared to the population in general. If you look at the median household income of a Notre Dame Prep student compared to the median income of this country in general, big difference there. You look at the geographic location, how far you have to drive to school. probably much higher here than on, than any random high school in general. So there's lots of things, both, so that's an example of ways that you're creating bias, right? So if you're looking at academic performance of high school students and you're sampling only from Notre Dame Prep, well, you may find that the thing that Notre Dame Prep students are performing well, but it might not because of the thing that you're trying to study. It might not because they're playing football. It might be that, well, our student population is more, is wealthier than usual, and that correlates pretty well to increased academic performance. It could be because the student-to-teacher ratio is lower than usual, and that has an effect on academic performance. It could be not any of the things that you're thinking of because of the place you chose to sample from, because your sample population is biased in some way, where you have more high achievers than usual. Another type of bad sampling method is a voluntary response sampling. That means that you send out, maybe you randomly assign or you randomly select 1,000 individuals, you send them a survey, and then you only use the surveys that come back. This often occurs in political polling, right? If you're polling on a political issue, how are you contacting people? Call them on a phone, right? So the people that are getting called, they have to have a phone. They have to be willing to answer a number that they don't recognize. After answering it, the number they do not recognize, and hearing that it's a political pollster, they have to agree then to take a poll. Who are the most likely people to do that? Only the people that have very strong opinions on whatever the issue they're being asked about are, right? It's the same thing you hear on the radio call-in shows. You listen to the sports talk radio. You don't hear the people calling in on the radio that don't really care. They're like, the Lions might be all right. That's not the caller they take. Who do they take? The guy that's convinced that it's the greatest team ever, or that the whole team is burning down, right? You don't hear the in-between, because those people don't call. Same idea here, is you overrepresent the extremes in a voluntary response situation. And again, this is classic problems with political polling. Another type of sampling that's bad is a quota sample. So this is different than a stratified random sampling in that it is not random, but it's kind of the same idea, but you're not doing it randomly. So you're you stratify your population, and then you pick the individuals from your stratum in a non-random manner. I'll just pick the first 10 boys on the list and the first 10 girls on the list, and I'm done. It's well, I guess it's better than just the nothing, but it's not, you didn't do much there, right? So the big key here in the quota sampling is it's not random. It's stratified, non-random sampling. And even worse is, you could do some kind of you do some kind of question at first before you allow the people into your sample. Be like, do you own a dog? Right? And if you answer yes, then I'll take some information from you. If you answer no, then I'm not going to count you. And you're like, oh, I collected 100 people. But the first 900 of them said they didn't have a dog. the 100 you collected that said they did, well, that population is like 9 to 1, you've represented them only, kind of thing, right? So that's another quotaing by having like some preliminary question to exclude, to separate the individuals into a strata, but like one strata has way more people than the other, and you don't represent them that way. Alright, so we do all this work, right? We define a population that we decide what we want to study, we hopefully do a good job and select a random sample, we do some careful data analysis and get some, some evidence of something going on. The last step then is to make an inference. So what do these statistics tell me about this sample that I can then transfer to the population as a whole? And this is why the random sampling is so important. So the random sampling ideally avoids bias. I shouldn't say avoid like I did here, because it doesn't remove bias guaranteed. But it's the best method we have to get as unbiased of a sample as possible. And then we have some additional bonuses. Because we're doing a random sampling, we can create a margin of error that says, oh, we found that, 57% of respondents say they're going to vote for this candidate, plus or minus 7%. So it could be as low as 50%, but as high as 64%. So we've created like some wiggle room to indicate the uncertainty we have with our prediction. And then second, we know that the larger my sample gets, the more reliable any statistic that I can generate is going to be. If I'm truly picking these people randomly, the bigger the sample gets, the less the odds of it being really biased in some way. They decrease, right? If I select 10 people, well, it's not, it's not very unlikely that I could select, like 10 women, right? If I'm just selecting 10 random people, not crazy to select 10 women only. If I select 10,000 people, it'd be really shocking to end up with like 70% of them women. That would be like an astounding coincidence. Where if I selected 10, that would probably happen, 15, 20% of the time. Right? Like if eliminated, we made it really hard to get like a crazy bias sample by just taking a bigger sampling. So oftentimes when we do we make our sample, then we have to collect the data from that, right? If you're asking questions to people, you also have to be really careful about how you're asking the questions, because you can bias your responses in the way that you're asking the questions, right? So, okay, we've talked about undercoverage, and we've talked about what I want to talk about is response bias, right? So, like, if I ask the question, do you agree that thing X is the worst thing ever? That's a crappy question, because I've made it so it's clear that I think it's the worst thing ever. People are more likely to agree with the question than if the better way is, what is your opinion of thing X? Like really bad, kind of bad, okay, pretty good, great. And I give you those five or six choices, right? Much less biased way of asking the question, right? So be really, again, many of you will end up collecting data from people. When you're writing your survey, this is like a thing to keep in mind, right? It's like, I want to make sure I'm writing questions that are easy to understand and aren't like prejudicing my response. The easy to understand part also needs to be not taken for granted, right? So, for example, let's say I ask, my survey question is, how much do you drink a day? What's wrong with that question?
Doesn't know what you're drinking.
What are we drinking? Okay, great. So we're talking about water, we're talking about alcohol, we're talking about soda pops, any liquid, what are we talking about? What's another bad thing about it?
Doesn't give like a specified unit.
Doesn't give you a unit. What if somebody answers 6 bottles? Another person says a gallon. Another person says 15 ounces. Like, this is like, you're getting like whacked. Like, what are you gonna do with that data? Like, that's a mess for you, right? Everybody's okay? Get what I'm saying?
Yeah.
So you gotta be careful with how you're asking. Another reason, or another example, is that sometimes the questions are just plain confusing. Is it true that I did not select no of these? Right? Like, how many negatives are you putting in some question where you read it, it's like, what in God's name are you even asking? Like, I need to symbol this out in a logical diagram to figure out what it is that we're trying to say. Like, you have to be careful to make sure the question is clear and answerable. So that's that. We're going to stop here in 7.1. You guys should be able to do problems on pages 216, 1 through 10, 216, I think it goes to 218. But there's 10 questions. These are all like, either explain something, or is this variable qualitative or quantitative, or like, what kind of surveying or sampling did this person do, or explain how you would use a stratified random sampling to collect this data. So there's no calculation. It's just like, these are all words, questions, and this is not uncommon for a while here. So you're gonna have a lot of homework that's just like explaining how you would do something, or identifying what this thing is, where there's no numbers to crunch here for a while. So hunker in, because it's not going to feel very mathy for a little bit here. Even though, in my opinion, math isn't really about the numbers. It's about structure and relationship, and like, what can I say about this thing given this information? That's really math. It's not like 1 + 1 is 2. That's arithmetic. Computer can do that better than me. What is the relationship in this, that this thing has to this thing? Calculator can't do that. Right? You need to have some higher level intelligence to do that. That's really what mathematics is about. Absolutely.
Six cards. That's how you do it.